Right, so if you already have Cura, this is going to be what it looks like. And if you're going to add a printer, it's click here where the printers is and add a printer. Now, if you're just downloading Cura, you're going to get a window appearing like this, asking you to add a printer. So we're looking at a non-network printer, hit the drop down, and these are kind of pre-made profiles for printers. We're going on custom and just go with a custom FFF printer, and let's give it a name here and call it clay printer, and we add our clay printer. Okay, so in the background you can kind of see what visualization of it, and now we need to set up our printer here. This is in millimeters, so if it's kind of, let's just say it's a 20 centimeter wide printer, 200 millimeters. Same in depth, and say 400. Yours might only be, 30 centimeter high, 300, but let's go with 400 for this that I'm setting up. And then I'm setting up a delta, so it's not rectangular, it's drop down elliptical, and the origin will be in the center. So there we go. Now another thing to watch out for is if by any chance you're setting up a commercial machine, something like a WASP, then this Marlin flavor for the Gcode is absolutely fine. But if you are setting up for a self-built machine, you'll find that in the software that gets put into the machine, often it says, the printer must wait for a temperature code to come up, and this Marlin sets a code. So what you need to be doing is actually go with the Ultimaker Gcode flavor, and what I find is then here's a kind of default start Gcode and end Gcode. All these codes get added to the file that then gets printed, sent to the printer. And in the start file, or the start Gcode section, this flavor adds some that we can't see at this stage. So it's a code that the printer will be waiting for as to whether it's wanting to, sort of get a reading for the nozzle or not. It's to stop plastic printers from starting printing until the nozzle is heated up enough. So what there is in fact a code, so it's worth even going with Ultimaker 2. This is for a self-built machine, Ultimaker 2, so no codes get put in here. And then even further to that, if you put in an M302 and give it an S that is kind of the temperature setting of 0, and then the M302 should be a code that tells it not to look for a temperature and will just print from cold. Right, so I've just come out of Cura to better kind of illustrate this Gcode flavor thing that's going on in Cura. I've made 3 files with different flavor settings. So you can see flavor Marlin, that I said is fine for WASP or something, but not for a DIY machine possibly. And then the flavor I suggested Ultimaker, so they call it Ulti-Gcode, but it's the Ultimaker, and then the Ultimaker Gcode flavor. And here is the M302 that I suggested you put in. So if you can have a look, I'm working in Windows where I've saved those 3 files. Okay. Now a Gcode file can actually be read with, in simple human language with a text editor. So for Windows, if I right-click on that and go to Properties, it says Open With, and I don't know whether you'll have a default program, but you can change it and change it to notepads. You might have to go to More Apps, but anyway, notepad is what you want, is OK, and then apply it to everything, and then OK. And then when you double-click on your file, you'll be able to actually see, you have to read it. So in the coding that gets sent to this is, what the printer's reading is if there's a semicolon, it doesn't actually read that line. So wherever there's a semicolon, this is put, sort of for us to be able to read or notes about the code. And then G-codes tend to be G's, and G1 is obviously the first code, and it's basically X, Y, Z. But then you also get N codes. I think there's some other codes as well. But what I wanted to illustrate here is that, where are we? Let's just get rid of that right out of sight. But going back to Cura in the background here, I said how there's this sort of header code, and you can see it written there. And that automatically gets put in there. But with the Marlin G-code flavor, you can see they've snuck in a bit of code just above that, that we can't see. And that's an M104 code that is, it sets the hot end temperature, and then an 05 that reports the temperature, and an 09 that is the target for the temperature. So basically, your machine will hang, it won't start printing because it'll be waiting for these temperatures to happen if you've got, a printer without a plastic nozzle to it. So that's, as I say, why I suggested you use the Ultimaker one, and you can see, the M82 as is where we're there is, from there down is exactly the same. Okay. And then what I suggested you do is actually type in this M302 that is a cold extrusion. So, that will overwrite any codes that otherwise, might be stopping your printer from printing. You might find that this code will actually, the machine will run because it won't be stopped by nothing, sort of looking for hot end temperatures. The machine will run, but then the screw won't run. And, if you've just got an air pressure or glue gun type simple printer, then that's all right. But if it has a screw, then this I find made the screw actually then start turning because it was happy to have a cold extrusion. So that's something to consider there. Then in our extruder, so we're going across to this tab, then the nozzle size, I suggest, I don't know what size you'll be going with, but 2 is a good default nozzle size, I find. And now we need to set up the compatible material diameter. Now, if by any chance you have a printer that it's just the air pressure that's pushing it through and you've got no screw, then you don't have to worry about this here at all. But this material diameter has to do with the flow rate. That is, once you have a print head that's got a screw in it, the speed that screw turns at and helps kind of extrude and control the clay is controlled by the amount of clay being fed into it, and that's this diameter. So a lot of plastic filaments by default are 1.75 millimeter. I actually, with clay, tend to work with a 1 millimeter, and this makes the screw then actually go faster. And to get that, we need to set up a material that also has got a 1 millimeter. So you could possibly get away with a 1.75 and just use a so-called PLA setting that we'll see in a moment. But anyway, I use a 1 millimeter. So what I then do is go next. So now my clay printer is set up, and by default it'll give me sort of a material setting for plastic PLA. Now I can go into the material settings through this drop down box and then down to manage materials, or I can go to settings and get exactly the same box through configure settings, and this configure settings then has general settings that we'll see later on, and then printers, and you can just see we've just put in the clay printer there, material settings, that's where we're about to go, and then profiles, that are your slicing profiles that we'll see over here as well. So anyway, back to material. So here's all the default 1.75 millimeter diameter. This is the range you can go from. But we want to set up a clay one. So we go create. And you can see over here it starts kind of going custom. So we're going to call it clay. And clay. And you can see down here it's starting to kind of build a custom clay profile for us. And call it clay as well. And we can give it its own color, kind of a terracotta-y color, say. Okay. So we now set it a color. And here you can see our clay profile has been built. But it's still set a diameter of 1.75. So we now want to change that to 1 millimeter. Now when we enter that, and you do have to go enter, it says that your print is not set for 1 millimeter. Do you want to continue? Yes, we do. We'll go and change the printer and say yes. Okay. Now with this settings window open, we can go back to printers, machine settings, for our clay printer, the extruder, put in 1 millimeter now and enter that. And I have actually got an earth setting in here. So let me just close this. That is also 1 millimeter. So Cura has gone off and found all the settings that are 1 millimeter. And we actually set up one that we call clay. That's the one. Okay. I could also use the earth because I've preset it up, but I want to explain it to somebody setting up a new system. So we've set up the printer, we've set up the material. Now we want a profile to kind of slice by. So I'm first going to add a file. It says where add from. And I, in my modeling program, have just made a simple cylinder that is 6 centimeter high, 6 centimeter wide. And this I kind of use as my default test the whole time. I kind of know roughly what it should look like, and I can, reprint it with different slices or different thicknesses and so on and so forth. Anyway, so we do need to have a 3D model in here to be able to kind of slice. So now we want, over on the right hand side here, is to, I clicked on at the top here, and this is where our profiles are. And they've got a sort of a simple system that is not adequate as far as I'm concerned for clay anyway. Clay is a bit more involved in this. So we're going to be doing custom settings. So we click the custom. So we end up with a box like this. Okay, the simple setting, the recommended was down there. Custom is there. We get rid of those coming and going like that. Okay. Now the default profile that they set up is a fine one. And what I would suggest under defaults, you can come down and start with the extra coarse as your kind of test piece. Okay, and so as a model, I press slice. It has sliced it, and now I want to see what that looks like. So there's a preview button there, and there's a preview button here. It doesn't matter which one, you'll get to the same place. And now there's, once you're in preview, you've got a slider here, and you can see kind of what it looks like. So, that's now a pretty solid clay object, and this has been set up for obviously printing with plastic, and it's potentially going to take 23 minutes. Now, we set a nozzle of 2 over in, you'd have to be in prepare, but when you have the printer over there, we set a nozzle of 2, so it's picked that up at least, and there's our nozzle of 2. So the line width is 2, right? So these are your slice heights. With a nozzle of 2, you could print at 0.6, but I think that's going to be pretty compacted. So you go somewhere between 6 and 8, and kind of 8 is going to be quicker. Then the initial layer height. Now sometimes this is visible, sometimes it's not. You might only have 2 settings in here, layer height and line width. And what one does here is if you go over one of these subheadings, so we're looking at quality now, this is kind of the slice quality, there's a gear, you click on the gear and you get, you know, the good old preference box coming up again. And now we're up in settings. So there's your printers and materials, and we actually are building a profile, but in the settings, here's your quality. And you can actually, I mean, these are kind of particulars that haven't been switched on yet. So the initial layer height, I've got a feeling might, in the default extra course, be switched off. So you would be left thinking, why is the first layer printing very small? Is because you can't actually see what the setting is. So by going to the cog, I open the setting, and now I can actually switch on the visibility of the initial layer, and there by default they tend to put it a proportion of the, you know, the standard layer. So I can now close that. This is my initial layer, and I print with my first layer the same, but you might want to make it smaller, and people do, so that the first layer is really well squished down. Anyway, so I think I'll just move into here. So now we're talking about the shell, kind of the build of the shell. So the thickness of layers, that's taken the same default as up there, that sounds about right. And then kind of the thickness of each layer, of a bottom layer or a top layer that gets made, is allowed for there. And sorry, it's disappeared. Let me just slice this again. So you can see now, I mean, the time has come down because I've gone to 0.8 millimeters. The slice is a bit fatter, so there's less layers, but you can see it's still got kind of infill going on here. It's got a base that's printed. If I slide this up, you can see it's also printed a top to it. So we want to sort of you know, get rid of these, or you might want to print those. But anyway, there's the top layer. Right? If I set that to 0 and slice again, now you can see that has been taken away. Okay. Now the bottom, you might want to print the base to your piece. I find that, I mean, I do print bases, but also you kind of need to know what you do, because you're printing with this very soft clay. They have a tendency to crack. If you're printing bases, you want at least 3 layers, if not 4 layers. But you may well switch this up to 3, or to begin with, I suggest roll out a slab of clay and just print straight down onto the piece of clay and then trim away any excess clay. So what we're going to do is set that at 0. Now if I slice again, you can see the kind of the base is not there. There's still infill and there's still a funny flange here. So let's keep going down here. So we've taken away the top and the bottom. Here we go, infill density of 20. So the higher the density, the more crisscrosses in here, and you can vary the shape and play around. But anyway, we're just wanting to print a straight cylinder, so 0, slice again, and now you can see the infill has been taken away. So we now still have this funny little kind of skirt going on here. Material, we'll come back to that, and the speed will come back to the travel. Here we go. Build plate adhesion. So in the drop down, there's a selection, and you can have a skirt that is similar to this, but it's just sort of one line, and you can vary how wide it is or how many lines you want. This is a so-called brim. I don't have any. I know some people sort of make one layer of skirt just to kind of get the clay going before they actually start printing. That's up to you. But anyway, so if I slice again, now that flange brim at the bottom has been taken away. So that kind of looks all very nice at the moment, but once you actually put it into your printer, you might find there will be some more problems. And one is the rate that the screw is turning. Now we've set a very small diameter, so it should turn quite fast, and that's often quite needed if you've got a small screw. But different size screws, sort of push out clay at different rates, and this flow rate is a combination of the air pressure as well as the screw rate. But anyway, start with 100%. You can actually on the LCD screen on your print, change the flow rate under settings, or if you feel the screw is turning much too fast, then you can reduce it here, down. And I've got some screws in the print heads that are very powerful, and I'll print at 30% speed. Anyway, so in time you'll need to work this out if you've got a print head with a screw in it pushing it through. Then the other thing to look at is the actual these speeds here. So again, the print speed is the speed that the head goes around when it's printing. On big machines, I do print up at 60 millimeters per second, but on smaller machines, it's somewhere between 25 and 30 millimeters a second. So anyway, for now, let's just go with 25. And again, you might find that some of these wall speeds are actually switched off. So outer wall and inner wall. So by default, you can see, let's just close that, Cura sets the actual wall printing speed at half the print speed. Now, I don't understand that, but anyway, I keep that as the same as 25. And then if you have to sort of set it up to print two walls, you might then suddenly find that the inner wall is going at a different speed to the outer wall, and this is where I know I just switched it off, but just in case it's not visible for you, there are selections for inner and outer wall. So let's just close that, and you can see an inner wall speed here was at double the speed, so I'm going to make that just the same as well. So basically with clay, I try and keep the speed constant all the time. The travel speed, this is the speed that the sort of the printer, when it starts off, comes down from the homing position, comes down and then starts printing. But it's also the speed that it might travel, if you've got an object that sort of has got two chimneys to it, it's the speed it travels, having printed the one side of the chimney over to the other side, it's the travel in between. And if it's too fast, it really jerks and pulls the clay. So I think you can be a bit faster than 25, but I go somewhere between 30 and 40. Initial layer speed, this is right at the bottom. If you kind of wanted to get going slower, up to you, once again, I tend to go. And then the number of slower speed is layers. Let's just put that at 0. So something like that is, a good start setting. One other thing to look at is the spiralize outer contour. So if you've got a single shell and you select that, hopefully when you slice it, you can see we write down at 9 minutes now because we've got, kind of no infill. Hopefully the path will just slowly spiral up, and you'll get your print. Now this spiralized, I've found it odd at times, but anyway, it might take a bit of experimentation. So what we now want to do, you can see next to extra course, we don't want to overwrite this. There's a star appeared, and that means that it actually hasn't been saved. So if we hit the save, we get our preferences box come up again. So we now go create, and it's basically creating a copy of what we've set up here. And when I name my profiles, I like to kind of remind up to you what you do, but kind of what my settings are. And so nozzle is one thing I do change. So it's a 2mm nozzle. And then the layer height or slice is 0.8 in this one. And then the shell, we've just got one shell. Okay. And now you can see the little star is gone oops, let's close that, sorry. In the drop down, the defaults are still there, the extra course is still there, but under my customs, here's the one we've just made. I mean, there's some previous profiles I have, but so selected that, and away we go. Now, if by any chance, with this, we've just got so-called one wall line count. So you want to make the your object much or thicker and heavier, you might want to say put in 2 walls here. So now what I'm expecting is there to be 2 walls, and I go slice, and I have a look, and oh dear, there's still only 1 wall. What's happened is the spiralize will only work if there's 1 wall, so we must just switch off spiralize and then reslice. And now you can see inevitably it's taking twice as long because it's building 2 walls. But anyway, that can now give you a much thicker model. And particularly I find, you know, with sort of very bendy shapes, then if you're building 2 walls, it becomes much more stable. So once again, the star has appeared because we've changed the initial profile. So what I'm going to do is actually make a copy of that, and then I can call this a 2 shell wall. Sort of as you let's just go back into the profiles and the settings of the profiles. As you can see, you know, sort of in any profile you can switch on these settings, and it's just kind of phenomenal. You know, well, my life's not long enough to go through all this. So once I get something going, I tend to stick with it. But you know, there are other things that I play with in here. So anyway, you can have a look, see what is of interest. I hope that's useful.